So it says that given the differential value, we have to go ahead and solve for y. So the first thing we're going to do is cross multiply. But really in the end for cross multiplying, I'm going to move the dt over and move the y over. And it's going to look like 1 over y dy. Am I recording? Yeah. dy is equal to negative 2 dt. And then we have to integrate to get rid of our dy and dt. Okay, when I integrate, hopefully y'all remember from your flashcard. Integral of 1 over y is natural log of the what? Of the what value? Absolute value of y. Later on, the absolute value is going to drop because it's not going to really matter. And then is equal to, we have negative 2t plus c. And again, we're writing plus c one time. Okay, it'll be any constant number. You're not writing with me. Do it right now. Okay, now this is going back to pre-cal. Okay, this part's not calculus. Let's put the hidden base e. Y'all remember dropping and crossing back in pre-cal? Even in algebra 2? If that sounds new to you, we're dropping the e. Cross the other side over as my exponent. And then y goes on the other side without the absolute value, because as long as the natural log is gone, we don't need the absolute value anymore. Okay? That absolute value is only there to give you restriction on the domain for the unnatural log. But right now it's gone. To further elaborate, I'm going to write y is equal to, it's really e to the power of negative 2t times e to the power of c. And e to the power of c, e is a number, c is a constant, any random constant. So if I were to rewrite this as one piece, it'll be c times, that's replacing e to the power of c, e to the negative 2t. And then I can put in my initial condition. They gave us x equals what number and y equals what number? By x, I mean t. T is 0, y equals 1. Let's plug it into this y and this t. And when I do, we get y is equal to c e to the power of 0. Is everyone okay with this e to the power of 0? And I forgot the 1 piece. The y was a 1 that I forgot to write out. So we know all this goes away. So really in the end, the value of c is equal to how many? 1. So now I'm going to go on to this guy over here and plug him in. So we have y is equal to, I keep forgetting that. My c value is 1. So do I have to write the 1 on there? If it's understood? Nope. E to the power of negative 2t. Okay, now let's see what I know. They said, what is the value of t when y is equal to 1/2, correct? Okay, that's my second step. So I'm going to use this value and say 1/2 is equal to e to the power of negative 2t. So here's the problem. My variable, is it on the bottom or as an exponent? When you have an exponent as a value, or the unknown, you have to do natural log on both sides. But that allows you to bring it down. So natural log of 1 over 2, I'm going to elaborate this. Using pre-cal, when something is divided by compressing, was it adding or subtracting when we expanded? We subtracted, thank you. So natural log of 1 minus natural log of 2. And here's what's unique. We have our hidden base of e. That is going to drop, meaning I have negative 2t on the other side. And then from there, let's do our algebra 1. What is natural log of 1, everybody? Thank you. What's natural log of e then? 1. That you have to remember. So that's 0. So I'm not going to worry about this guy at all. So if I'm solving for t, all I'm going to do is divide it by negative 2. So negative natural log of 2 over negative 2. And what's going to eliminate from the top and the bottom?
The negative.
The negative. So what answer is correct? C it is. Now let's go on to number 3. Number 3, I'm going to actually do it on the worksheet because it's got enough room. So here I go. So number 1 was quite intensive. I get it. Okay? The remaining 2 is very simple. So for the next one, we have to integrate. So when I integrate, we're going to get, let's go ahead and put on here, let's go ahead and separate them first. I'm going to separate it by saying dy is equal to, we have secant square root of x dx. Okay, this is going to test your integral with the trig. What is the integral of secant?
You mean secant squared.
Secant squared, thank you.
It's tangent
It'll be tangent, but let's write something unique here. Put understood 1. Integral of 1 dy is basically what? Y. And then integral of secant squared is tangent plus c. And then they gave us the initial condition. They said when x is 0, y is 5. Let's plug that in. Y is 5. Tangent of 0 plus c. Do y'all remember how to find a tangent of 0? What is tangent of 0? Ooh, let's kind of recall pre-cal real quick. Here's 0. The order pair of that number is 0, 1. Tangent ratio is opposite over adjacent. We all remember that, right? Opposite is the y movement. What's the y movement in that order pair? What is my y? What is my adjacent? So we know tangent of 0 is going to be 0. So that means my c value is simply 5. So if I were to plug this back in, it's going to look like A, B, C, D, or E? D it is. And I'm plugging the c value back in here. Then it looks like y equals tangent x at plus 5. Now let's go on to number 12. Let's all get to number 12. And I have it right here. All right, 12 I'm going to use the same way as I have taught 6.2 on the matching part, okay? All right, so looking at this, the fastest way to go about this is all the flats. So I'm going to highlight my flat surfaces. So highlight all the flats. If you want to emphasize it by making it thick, that's up to you. Okay, so let's see what is happening then. I want to worry about this guy right here. That order pair is -1, comma what? Comma 1, and that's representing the x-coordinate and y-coordinate, correct? So if I know I need a flat surface, meaning the slope of 0, would you agree when I add the x and the y, they become 0?
Yes.
Okay, did y'all hear what I just said? Adding the x and y? Which option has that? Done. That's simple.